Hello everybody. So, we have discussed on working stress method used in IRC 21 and also IS456 also. Now we shall go for working stress method, we shall go for, on that, and then that is as per IS456 first, because you are very much familiar with IS456, and then we shall go to IRC 112, that is for the bridge used, that we shall go for that concrete bridges used, that we shall go for it, and then we shall compare that the difference method, that whatever we are going to use it or whatever methods available. So, this is our lecture number 7 on reinforced concrete road bridges, and then we are coming back to that limit state method, and which will be as per IS 456 2000. And we are again considering first limit state of collapse, that is flexure, because our objective here in this particular course, that mainly it will be governed by your flexure and your shear. I have told it a number of times. So, let us check with the flexure only. And again we are having certain assumptions, and those assumptions again you see that on the first assumption, plane sections normal to the axis remain plane after bending, the maximum strain in concrete at the outermost compression fiber is taken as 0.0035. So, please note this particular aspect, that in working stress method we are totally silent. Only thing we have told that strain profile will be linear, straight line, that much only we have told, but we have never given you any number that how much will be the strain, but here we are giving certain limiting value of strain, and that is 0.0035. The tensile strength of the concrete is ignored as usual, because there is no such difference with the working stress method and limit state method. Here we are ignoring that too. The stress block may be assumed to be rectangle, trapezoid, parabola or any other shape which results in prediction of strength. Please note the next one, that substantial agreement with the results of test. So, that means the code agrees that it will not exactly, it will not match. So, that is why the code is that very wisely it has told that substantial agreement. So, this why that is the one you should understand, that particular one, that particular term, the substantial agreement. So, that means it should come very close, no doubt. So, but otherwise you can use any other one, and I shall tell you that one also. That is why I have taken this particular one, that working stress method, limit state method by IS 456, and then we shall go for IRC 112, that we shall go for it. So, that we can I can show you the one way, that evolution, another way the journey, that how we are going from elastic to the beyond elastic, that particular one, and really it is very interesting to note those things. Only thing I would like to say, that note this triangular as in the working stress method. So, this is the one we have taken, that I have told you rectangle, trapezoid, parabola, like that, but here we are taking say triangular in the working stress method. This is the one difference that we are having. The stresses in the reinforcements are derived from representative stress strain curve for the type of steel used. So, which type of steel you have used is dependent on that. For design purposes, the partial safety factor, because you see that one last time in working stress method, certainly I have told you partial, but I have told no, that partial we are not going to use it for working stress method, but here we are going to use the term partial. So, the thing is that in the fifth lecture, just I have given you idea, though it may look like to you that why that particular that one lecture was given on the design principles, where that probably, because I feel that particular one there is no such scope to understand the that you say that how the code is made what is the basic principle, the reliability index, other things. So, that is why I have given you that just only half an hour one, though it may look like it is little bit very fast, but anyway just to give you idea, but the reference book which I have given, from there you can get more information if you are interested, and that is very interesting also. But the basic idea there, that calibration of that partial safety factor, that one is important, because this partial safety factor, it is coming for different materials, for different cases, for say loading, you will get different actually factor, you will get it. It is not like working stress method you are having only one value. This is very very important, and here we shall get it say 1.15, that we shall take it here. The maximum strain in the tension reinforcement in the section at failure shall not be less than Fy by 1.15 ES plus 0.002. What I would like to mention here, for concrete, irrespective of grade of concrete, we always give 0.0035, that is the limiting value of strain. But in this case, we are giving that value depending on the grade of steel. So, Fy by 1.15 ES plus 0.002, this is the value that we shall consider. That means, for different grade of steel we shall get different values. So, this is the one that figure which we have taken that here, you are very much familiar with that. So, first this is the one FCK, next we are having from the designer point of view 0.67 FCK, which is nothing but 2/3 of that. Then you are getting 0.67 FCK by gamma m here it will be 1.5. So, we shall get, which is nothing but 4/9 FCK, 2/3 FCK into 2/3 of that will come here. So, 4/9, that means 0.444, like that you will go. So, generally we write down 0.445 or 0.45 FCK, that we write down, that means FCK is the strength of the concrete, and we are going for that 0.45 FCK, that is the value we take it here, that particular one we can consider. Now, this is the for cold work deformed bar, again here getting this is the actual one, and we are getting this one here Fy by 1.15, and that value we get it here. This is for mild steel. So, this particular one again you are getting Fy by 1.15. So, this value we are getting up to this same, after that we are getting little less. Coming to this one here. So, this one, whenever I have shown that figure, I have not shown you any value in working stress method. Here we are taking this particular one here AST, B and D, X, this is the neutral axis. So, this portion only we have written that value, because here we have not told what is the value here, but here I know what is the value this one for steel, what is the value for the concrete, there is always maximum 0.0035. This is 0.45 FCK we have considered. This one I am telling that particular 1 CK2, they are actually you have told this is the x, so x by 3, that is very simple, because this is a triangle, but in this case it is not a triangle. So, that is why you are getting that value here, that particular value you are getting here, that you can find out that your sum value will be there K2, that particular value you have to find out, and this is the one in the tensile stress, tension force in steel, and as usual that you would say tensile stress in that concrete, that is actually this particular portion ignored. So, only we are having compression, concrete will take the compression and this one will take the tension. So, K2S is the distance of the center of compression in the concrete from the top compression fiber. So, we can find out that K1 and K2, this one area of rectangle, the top one minus area of outer parabola. So, if you make this particular one simple calculation, then I can get it 0.364 FCK x into B. So, K1 means 0.364. So, this particular one, please note this particular one 0.364. Again, this is a very very important one for limit state method, and we are talking here IS456 2000. In this case, we are taking certain portion and this C which is coming as 0.364 FCK x into B. So, this is your x, this is 0.45 FCK and B is the width of the beam. So, this particular one we shall note down this particular one, and which we are talking this one K1 FCK x into B. Further we can make many more things, we can do it, that I am not going to all detail all those things, but I am keeping this one for the time being, that particular value where we are telling that Q1 equal to 0.364. Because why I am noting down this particular one, again I shall show you this particular one later on. Coming to this one here, so another value of K1 and K2. So, this K2 we have to find out where is that K2, K2x. C we know, taking moment over neutral axis we can find out all those things 0.364, that area of this one x into B, x minus K2x, 0.45 FCK x, this is the rectangular part, and then we are finding this particular one is the that parabolic part, this particular portion we shall deduct. So, 1 minus K2 equal to 0.584. So, let us note down that K2 equal to 0.416.42. So, it is very important here K1 and K2. Why I am trying, what I am trying to say this particular one here. So, that means see this one, that all equation can be written in terms of K1 and K2. That is our objective, that particular one. We have taken a parabolic shape, certain say parabolic rectangular shape, you can say more precise way. So, if we take a parabolic rectangular one, and that particular one we can define with the term sum K1 and K2. That means, C will be equal to Q1 FCK x B. Similarly, we can find out your say value of M also. So, C equal to Q1 FCK x by D B D, T equal to 0.87 Fy AST. So, let us write down that one here also, T equal to 0.87 Fy AST. So, this is your C, and this compression in concrete and tension in steel, and this is called, again I think I have not told so far, again I am telling this particular one here, that a singly reinforced section. So, this is your singly reinforced section. It means that compression side, even though steel is there, that one in ignored. That means, whether it will contribute or not in your momentary resistance, we do not know. So, but that portion actually ignored, that one. So, just to complete this particular one, I would like to say, similarly we are having doubly reinforced sections also. Doubly reinforced means the compression will, in the compression side also steel will be available or will be provided. Sometimes we do it. So, coming to this particular one here, this is the situation we are getting it here, and as usual this C and T, that one should be equal, the C and T, that one will be equal. So, C and T we know, and we know this one equivalent 0.87 Fy AST equal to 0.364 FCK BXU, that particular one we can find out, and then we can write down here mu equal to K1 FCK x by d 1 minus K2 x by d b d square. I have taken all of them together. Actually, here your K1 FCK x by d b and b d, that factor we can take it here. So, this one, just to complete this factor, I can write down here what I can do 0.364 FCK x by d into b d. That is what I will say. K1 0.364 is nothing but K1 FCK x by d into b into d, and this portion is coming from the lever arm. So, this portion is coming from the lever arm. So, that means actually whatever I am doing mu equal to C times Z. C is this much, C is this much into Z. Z means this particular one here, this is your Z. So, Z equal to d minus K2 x equal to 1 minus K2 x by d into d. So, 1 minus K2 x by d into d, this factor here, from there I am getting one d and from there I am getting another d. So, that is why it is coming mu equal to this factor 1 b d square. So, this is the equation you are getting for mu. So, similarly, just I would like to make it in one page, that is why I am becoming little miser. So, let me write down that one mu equal to T z 0.87 Fy St into z, z again will be equal to 1 minus say K2 x by d. So, this is the one term which you are getting due to steel. So, this one you are getting. So, now what I would like to say that K1 FCK x by d, all these equations whatever you are writing, that one you will find out later on that it will be independent of any method, whether it is working stress method, whether it is limit state method, whether it is IS456, IRC 112, you will get this type of that equation, that format of equation you will get it every time. That is what I would like to say, and that one we shall come back later on if we get time, because main objective you will find out that it is not just only a formula you are using, you try to understand the formula and from there you find out the little difference, little modification, how it actually affects or how which that particular parameter actually affects, that also we can find out. This one is very important. This particular one you can say very important here, that J equal to 0.5 plus root over 0.25 minus mu by 0.87 FCK b d square. So, I think this particular one we can find out from the equation mu. So, 0.36 we can write down here FCK x by d 1 minus 0.416 x by d b d square. This equation it will give you FCK BD square So, I am rearranging this particular equation. And from there you can find out here So, I am taking this equation in one place plus FCK. I could omit this portion, but I feel that whenever you are going through a problem, so it is wise to go for that. That is why I have taken this particular one. I could refer this one to your reinforced concrete one, that way we can find out. But anyway, so we can find out this one here. Taking this particular one here, we get it here. I am not going to, so you are advised to go in detail. You can get this particular one in P.C. Varghese book of limited design of concrete. And this one will give you, just I am writing the final one. .68 mu by FCK BD square. So, this is the one you will get it, this particular one you will get it in that particular you will get it here. Now, further I would like to do it the J one minus 0.416 x by d equal to 1 minus 0.416 into 1.2 plus 0.416 root over 1.2 whole square minus 6.68 mu by FCK BD square, which comes as 1 minus 0.499 plus, if you just inside if you take it 0.249 minus 1.156 mu by FCK BD square, which is nothing but you can say 0.5 plus root over 0.25 minus 1.15, I am writing down mu by FCK BD square. This particular one we can write down here. So, J further very interesting way I can write down 0.5 plus root over 0.25 minus mu 1.15 divided by that one. So, 0.87 FCK BD square. So, mu by FCK BD square, that mu whichever the force the moment actually applied due to load, and FCK B and D, on the basis of that I can find out, and then I can decide the value of J, and whenever we shall decide the J, and then on the basis of that we can find out many more things. So, this particular one J we can find out. So, J equal to this one. So, that means here 0.5 plus root over 0.25, very interesting, that beautiful numbers, easier to remember also, and we would like to see that particular one whether it is valid for other cases also. So, only this portion will change, that will change lot of things, will influence the whole idea mu by FCK BD square, this particular one. We can tell something this mu by FCK BD square. So, we can say this one as say k equal to mu by FCK BD square. So, we can write down this one as J 0.5 plus, just let us distinguish this one, 0.5 plus 0.25 minus 1.15 divided by k, sorry, k by 0.87, or we can write down 1.15 k also, we can write down this one. So, that also you can write down either 1.15 k or k by 0.87, that way also you can write down this particular equation. So, this k is a very very important one, because it depends on that whether this one is going to be negative, that negative. If it becomes negative, so we shall not be able to solve it. So, that is why this mu by FCK BD square, this is a very very important aspect, because I know mu because it is coming from the load, I know FCK because which grade of concrete you are going to use, you also already you have decided. B also we know, only thing that one that you can change it, that is the depth of the beam. So, this changing this depth D, so that one should be always less than 0.25. If it is greater than 0.25, then it will be a complex number, and which is then means it is not possible, it is not feasible. So, this particular aspect we have to find out such a way, so that I can get certain value of J. So, that means here J can be 0.5, because if we make such a way that 0.2 is 0, so that means we can get say minimum, that is a J value of that 0.5 here. So, coming to this particular one here, just to give you idea, as per IS456, mild steel 250.0031.53, high yield strength 415.0038.48, high yield strength that particular one 500.0042.46. We are getting this one FY by 1.15 ES, ES that modulus of elasticity of steel, that one we considered here, always same 2 into 10⁵ Newton per square millimeter. XYD it changes with respect to steel, that XYD that changes, and then X by D, that your say PT Fy by FCK, this value it gives you your that value, it will give you that balance section. Later on whenever we solve the problem, that time we shall come back to that particular one here, and the maximum limiting values of compression, this particular one we can say. So, we can say steel for our XU by D K1 same for all of them, K2 and F, that particular one we can find out XU by D is varies with respect to that. Similarly, F will also vary with respect to that. So, as usual the same thing, balance sections already we have already told, so that I do not want to come to that. under reinforced sections, that also we have discussed, that an over reinforced section, that particular one we have considered already, we have told these values. So, this is very important here. So, that means here whatever we are considering here, why I have chosen that IS456, because it will because since you are familiar with that, maybe that you are not familiar with working stress method, those who are taking, but that is also another important actually method that we should never forget, because that is the very basic one. After that we have come, and considering all this aspect, what I can say that particular one, from the linear triangular one to the parabolic rectangular one we have considered, and because then finally we shall come to that IRC 112, and not only that, you will find out that code, that is actually Euro code, where you will find out that particular one Euro code. There we will get also similar kind of thing, whatever actually you will find out in IRC 112. So, considering all aspect, though I thought I shall tell you regarding the CR part also, that we shall tell you when we shall solve the problem, that time we shall discuss. So, with this I think whatever we can say, that particular one, we would like to actually conclude this particular one with respect to say IS456 2000. The next one we shall go for it, that is IRC 112, and what is the difference, that we shall find out. So, with this we conclude this particular session. Thank you very much.